Okay, so instantaneous velocity. So what is this instantaneous velocity? It is the velocity of a body at a particular instant of time. Now, what does that mean? Okay, the velocity of a body at a particular instant of time. For example, let's say you're traveling in a vehicle or maybe a car, and let's say you're sitting in the front seat of the car, and you will see a meter in front of the steering wheel of the driver, and that meter, it measures the speed or the velocity of the car. So when the driver is pressing on the accelerator, you will see that the meter also increases. So that meter, called the speedometer, actually measures the instantaneous speed of the car, which gives the value of the speed at that particular instant of time. Like the average, where you take in this particular time interval, you find the average speed. No, this is at a specific time. What is the speed of the body? That gives the instantaneous speed. So similarly, the instantaneous velocity, it is the velocity of a body at that particular instant of time. It is defined as the rate of change of displacement. Okay, the rate of change of displacement, and it is given by this. All right, we use this notation. This is a mathematical notation called the limit. Okay, this is displacement by delta t, which is the time interval. Okay, so delta x by delta t, this is nothing but the average velocity. So we can also say that it is defined as the average velocity taken over a small time interval. So when delta t is tending to 0. You see this arrow here. How do we say this? This is limit delta t tending to 0. That means if the time interval is very, very small, so that we get that particular instant of time. So this by definition is equal to dx dt. So the differentiation of the displacement with respect to time. Okay. All right. So let's say we have something like this. So instantaneous velocity, this is equal to v, and this is nothing but limit delta t tending to 0. Sometimes I write lim, or sometimes I write only lt of delta x by delta t, right? So here only this part, what is it equal to? This part is nothing but the average velocity. Okay, so we can reform the definition as how do we redefine it? As it is the average velocity taken over an infinity, infinitesimally, infinitesimally small time interval. Okay, so this is another definition for the instantaneous velocity. Let me repeat. It is the average velocity taken over an infinitesimally small time interval. Now mathematically, how do we denote this line? When we say infinitesimally small time interval, we mean that the limit delta t is tending to 0. Okay, this arrow means tending to 0. So it doesn't mean that the time interval is 0. No, time interval is not 0, but then it is nearly approaching 0. So that is the meaning. So limit tending delta t tending to 0 of average velocity of del x del t, that gives us the instantaneous velocity. Okay, and this by definition, you will learn this definition, that if you do this according to your maths, this is nothing but dx dt, which is the differentiation of the displacement. So again, we can say here it is the rate of change of displacement. So if you have v is equal to dx dt. Okay, let us do some numerical problem. For example, let's say I have something like this. Let's say a body a body, or let's say we have the, not a body, let me reframe the question nicely. Let's say the position of a body is given by x, which is equal to, let's say, 2 t square plus 3t. Okay, where x is in meters and t in seconds. Okay, calculate number one, let us calculate the average velocity of the body between time 2 seconds and, let's say, between 2 seconds and 4 seconds. Between 2 seconds and 4 seconds. So that means the time interval is given. So between this time interval, so what will be the average velocity of body? So secondly, let us find the instantaneous, or we can just say the velocity after 5 seconds. Okay, so this second part of the question, to find the velocity of the 5 seconds, you see here, you to find between this time and that time, just like in the first case. So because of that, it means that they ask you to find the velocity exactly after 5 seconds. So that means at that particular instant of time. So what type of velocity are they asking in this second part? They are asking the instantaneous velocity. Understand? So you be very careful when you read the question. Okay, so if they give the time interval like this, that means it would probably be average velocity. If it's after 5 seconds, maybe after 2 seconds, after 10 seconds. So from there we understand that they are asking about a specific time. So when we talk about specific time, we are actually dealing with something instantaneous, like instantaneous velocity. Okay, now how do we do this? All right, let us do one thing. X and t. Okay, so we already have this equation for x. This is x is a function of time, 2t squared plus 3t. All right, so let us do the first one, number one. So let us put this to be t1 and this to be t2. So if t1 is 2 seconds, then what will be the value of x1? You see here, this expression, it gives the position of the body with respect to time as a function of time. So by putting the different values of time, we would get the different values of x. Okay, so that means at this time t1, let us put t here by 2 seconds, you will get the value of x. So x here will be 2 into, instead of t you write 2 seconds, so that will be 2 square plus 3, 2. Okay, so here you will get 2 square is 4, 4 into 2 will be 8, 8 plus 3 2 is 6, so that will be 14 meters, since x is in meter. And then when t2 is 4 seconds, what is the value of x2? Again here now, instead of t you will write 4, so you have 2, instead of this t you write 4 square plus 3 times of 4, so that will be 16 into 2, that will be 32 plus 3 4 is 12, so that will be 44 meter. Okay, so therefore average velocity, okay, this is what, this is x2 minus x1 divided by t2 minus t1. So x2 here is how much? This is x2, and that will be 44 minus x1, which is 14, divided by t2 here is 4 minus 2. Okay, so 44 minus 14, so that will be 30 divided by 4 minus 2 is 2, so that will be 15 meter per second. Instantaneous velocity v is equal to how much at a time t is equal to 5 seconds. we know that v is actually dx dt. Okay, so let us differentiate this first. So that is why I told you that you have to learn your differentiation. If you don't know differentiation, you will never be able to do this. 2t square plus 3t. 2t square plus 3t. Okay, so I differentiate this, so that'll be 4t plus 3. All right, so that is the velocity. Okay, so therefore at t is equal to 5 seconds, now you put the value of t. Okay, what will be the value of v? That will be 4 times of 5 plus 3. 4 5s are 20 plus 3, 23 meter per second. Okay, so is the average velocity and the instantaneous velocity the same? It's not the same. Make sure that you don't substitute time in the expression for x. Okay, you first have to differentiate this to get the expression for velocity. Then in that expression for velocity, now you substitute the time. Then only you will get the velocity at that particular time, which is the instantaneous velocity. Okay, all right, so I think that is done. Let me give you one example. No, let's take it to be homework. The position of a particle is given by x is equal to, let's say 3t square minus t. Okay, where x is in meters and t after 10 seconds. Okay, so here the first part they are asking about the average velocity, and then the second part about the instantaneous velocity. Do this as a homework.